right, I'm finally doing it. I'm going to show you how to make your own Nano Node. That's right, from A to Z, we're going to go through every little step, every itty-bitty detail, every environment configuration, so that you can be the node operator you've always wanted to be, and write your own nano software and use this thing as your own source for interacting with the nano network. I'm very excited about this, and you guys have asked me left and right to do it. Basically, I made this article, which if you follow it along step by step, you'll be up and running in no time, okay? It's very straightforward. But I understand that, video can help some people out. It's good to hear the actual justifications for some of these things with words, because, there's just so much to it, This is a very complicated thing, as you might expect with Nano, but if you stick with me, you're going to know how to do it. So, you can just read the article if you want to, but I suggest you follow along with this video, and if you have any questions, feel free to reach out to me, okay? I go by SaunderDev #9364 on Discord. I'm constantly helping people out with setting up their nodes. Even the Nano Center used my guide to do it and had to ask me for some help. It's a complicated process, but we have people in our community who are more than happy to help you out, myself included. You don't have to do it alone, but anyways, without further ado, let me show you my best effort in getting you up and running just from a video. So, we're going to be making a rep. I know you know what that is, but the particular reason I'm doing this, just in case there's any criticism oh my gosh guys, we don't need more nano nodes or whatever, we need more nano software, and you gotta have a node to have your own nano software, right? It's just your access point to the network. I know APIs exist, but it is what it is. So, without a node, how can you really get into the nitty gritty of accessing it and doing all this cool stuff with money transfer and, just all the things that interacting with a digital source of money, requires. So, all right, without philosophizing too much, basically, we're going to be making a node. I'm going to show you two responsible usage, how you're not going to get totally screwed over, and more importantly, how you don't screw us all over. Because if you use the wrong hardware, or set this thing up wrong, or have terrible uptime, or what have you, right, you actually can hurt Nano in a way. If people are delegating funds to you, and you're not responsible with it, if you're not there actively representing their interests, right, to be running this fast, feeless green currency, all that jazz, then you might as well not run a node. So if you do all the stuff that I say, and, just give it your best effort, it should be great that your node is part of the network. So, all right, you need to make a rep. Now, you got to decide what computer you're going to run this on. I personally choose to run it in the cloud. You might be thinking, well, hold on. Doesn't that mean I need to pay a monthly rate? That's true. You got to actually go rent some server. Maybe rent it from Amazon. Maybe rent it from DigitalOcean. We're going to use DigitalOcean for our tutorial. I think it's the most straightforward, and you'll see why in particular soon. You could do Hetzner. There's a whole lot of options, but just keep this in mind. If you do want to run it from your house, you got to make sure that your internet connection is like a enterprise-grade data center's internet connection, okay? Network throughput is super important, especially upload time, okay? You want to make sure that, you're not constrained like a normal home internet network might be, at least in the United States, in terms of bandwidth, so that your node can just be, processing everything efficiently and getting these blocks voted on and all that. So, hardware is important, networking is important. I'm going to show you how to do it in the cloud. Everything you see in this tutorial, you could do at home. Just keep that in mind. And also, we're doing DigitalOcean in this guide, but this is exactly the same everywhere else. Yeah, there might be slight little things you have to change, but because I'm showing you how it all works, you should be able to figure it out if you do a different setup. Now, with DigitalOcean, I recommend you sign up using my affiliate link right here. Okay, I got some heat for this from someone on Reddit about it, but I need to explain why I'm doing this, okay? My affiliate link will give you $100 of free server credits, so you can actually go and, for free, run some great enterprise-grade hardware, and it gives me a little kickback. That kickback, I have exclusively put towards nano projects directly. I don't mean, every time I've earned $1, I've gone and spent it on, my time or whatever. No, I mean, literally running my hardware, okay? That is what this money has gone to. Not a single cent has left, running DigitalOcean projects for you guys. So, you get a little credit, you don't pay any more, and you get to help fund my Nano Node because I use some great hardware, as you should too. Okay, so sign up with my affiliate link. You'll be able to set up your own droplet, and I'm going to show you now how to do that, but you'll need to actually click this one. I'll leave a link to it in the description too. So I'm not going to actually scroll through this guide because we actually have DigitalOcean right here. So it might look a little different when you first sign up, but this is DigitalOcean, and we're going to use it to make our first server. They call them droplets. That's just a branding thing. If you were on AWS or Hetster, they'll do something else, but it's like a droplet in the DigitalOcean, haha. So you'll either have this green create button or this blue get started. They're the same thing. What you really care about those, once you click it, you'll be on this page, and that's where you get to make your system. So first, you choose your operating system. Just choose Ubuntu 20. We're not going to get into the nitty-gritty on why you might do something else. Yes, it's technically better for the ecosystem if we're all running different units, but just go with the easy stuff that everybody's doing, especially for your first droplet. But yeah, so that's the first thing. The next thing you're going to do is choose your plan. Now, these have changed over time. They're always coming up with some new, we've got our new storage optimized servers. Hey, look at that. You could pay $1,000 a month for what's a pretty sweet piece of hardware, but we don't need that much compute power. So I personally prefer to go with something like this general purpose node. Maybe double the storage for it. We're going to actually add some extra storage in a second, so you could go with this one SSD. But the reason I like this one in particular is the CPUs are hardware CPUs. They're not virtual. And what that actually means is that, you're not having to share your cores, okay? It's not like you're competing with other people using the platform to run processes on your CPUs. Now, okay, to be completely fair, guys, you could just go with one of these basics, but I just think, in the best interest of the network's health, go buy the right hardware. Go get some good stuff. At least spend $40 on this. I'm going to show you a good setup that if you've got the money, just do it. If you don't have the money, either don't run a node because it will slow the network down if you don't, all right? Or maybe, get with a friend or something and you guys just pool your resources together and then you go run your node because it's just really important for our network's health that everybody be fast. Now, how fast you need to be? It's a little more complicated than this, but basically, if you just make sure you're faster than everyone else, you should be good to go. So we're going to do our $60 a month, nice extra SSD node, Ubuntu 20, and then we're going to, start playing with some of these options. Now, we could do this later. We're just going to do it now. We're going to add a volume that will store the actual block lattice, and we do this so that, if in the future you need to increase your space, you can increase the size of this storage block. You see, if you were to put the block lattice on this SSD, or equivalent, depending on what node you buy, you could fill all the space up, and then you won't really be able to upgrade that easily. Now, maybe DigitalOcean will change it in the future where you can actually resize these SSDs, but as it currently stands, from last I checked, if you want to really start changing the size of volumes, you need to use a block storage device, and that's totally fine. You'll be able to get the performance you want out of it. So you pick a size. I like powers of 2, so we'll say, for $12.80 a month, a 128 gigabyte block storage device. Now, importantly, you want to make sure that you're over twice the size of the block lattice, okay? So if the block lattice at the time you're watching this video is 50 gigabytes in size, make sure you buy one that's at least 100, okay? There's a specific command that you may use way later on, okay? Not anytime soon, but way, way later on when you really know what you're doing, you might use that requires you have double the space. Maybe they'll change that. Maybe there will be some change in the future such that you don't need all that space, but just for the time being, give yourself some room to grow. So we're going to get that. It's fine to automatically format and mount. We're going to do the ext4 file system. That's the nice default. Ubuntu knows how to handle it. Not that it doesn't know how to handle the other stuff. All right, there's a million asterisks to everything we've said here. If you know what you're doing, right, you can play around with that, but just go with the defaults, all right? Okay, so a really fun decision that you get to make is where to physically locate your node. So I'm going to pick the first data center in New York. my reasoning for it is that it's close to where I live, so I guess I've been doxxed, but anyways, it's going to be quick to access it. You know, if I were to go put a node, as I've tried, in a foreign country, I would notice a delay when trying to communicate with it, and for my own personal sanity, it's just nice to be able to quickly communicate with my node, because I do a lot of nano programming. But there is a reason why you might pick a faraway node, and it's that, in the sake of the network's health, it's probably best for risk, right? If everybody was to go sign up for DigitalOcean and put all their nodes in New York 1, and New York 1 had a catastrophic event, maybe it's a power outage, maybe a meteorite destroys all the server racks, whatever happens, that could be a serious issue for the network because those nodes would be offline. So, if you're following this guide, maybe pick New York 3, maybe pick San Francisco, depending on where you live. If you're in a foreign country, you know, choose Amsterdam, whatever. Just pick something that hopefully other people aren't picking. And if we all kind of pick at random between the nodes, between the data centers that are close to where we live, we should be all right. So, yeah, so you pick your data center. I will say for future nodes, you're going to want to pick the same data center. So if you maybe set up 2 nano nodes, or you have a nano service and a nano node, having them in the same data center means they can communicate with each other in ways they couldn't if they were in different data centers. And be advised that just because 2 different data centers are in New York doesn't mean that they have anything special between them, all right? New York 1 and New York 3 are as different as New York 1 and Amsterdam 3. So, you know, there's just some background on that. As for additional options, you can enable IPv6. We're going to purposely set up an IPv4 node, but it doesn't matter. You can pick that. I've never done user data. I enable monitoring. That gives you some like metrics you can look at with your node. All right, and then you're going to actually set up authentication. So the way we'll do that is through an SSH key. You can use a password, but please don't. It's just less secure, and this is just something you got to know how to do, okay? Like, if you're going to be doing a lot of programming and stuff in the future with your nano node, like, trust me, you'll be happy you did this, okay? So you're going to make an SSH key. This is the first thing that requires the terminal, and actually, I guess we'll come back to it in a second. First, give your server a name that you like. Maybe we call it like Nano Node tutorial or what have you, but shoot, what should I call it? Maybe guide, because my node is going to guide you guys into making your own. You can add some tags. These are just for like, looking up your node in the future. I'm not going to add one. Your project, and enable backups, okay? You definitely want to do this. You don't want to lose your seeds. I mean, you should back this stuff up at home, obviously, but, just play it safe, okay? Back up your stuff. Okay, so now back to the SSH key, because this is the complicated part. It's the last thing we need to do before we can actually run this node. So we're going to make a new one, and what that's going to require is that you create 2 keys. This is kind of like Nano, where you have a private key and a public key, except it's for SSH, all right? SSH being a mechanism, or rather protocol, by which you're able to communicate with your node, all right? So there is this command called SSH keygen, and you're going to have to run this from your terminal, all right? If you're on Windows, good luck. If you're on Linux or Mac, this is how you do it. So what you're going to do is go to your terminal. Let me do that, all right? And run that command, SSH keygen. So it'll ask you where you want to put it. I am currently running this command from a directory where I purposely keep all of my SSH keys. This is just a standard directory. If you don't know what directories are, that's a bit too basic for this tutorial, but, you just, from wherever you want, making sure you can always get back to it, of course, pick somewhere that you want to save this file to. So I'm going to actually call it guide in the local directory. It is going to make 2 files, guide and guide.pub. Don't pick a passphrase, you don't need one. And those 2 files will essentially act as the 2 halves to, your authentication scheme. So let me actually show you those. I'm only going to show you those 2 key files. I have a few other in this directory I don't want to show you. That's why I added this filter to only pick listings from this directory that have the word guide in them. So you've got 2 files, okay? Guide and guide.pub. This is your private key. Do not show anybody this. And this is your public key, which of course the world can know. It's just like Nano, your seed and your public key or account number. So I personally also like to name it .pem. That way you have a pub and a pem. You'll find this all over the place sometimes. Somebody's gonna get very mad at what I just did there, but whatever, you just have your two keys. One's your private key and one is your public key. And DigitalOcean doesn't have to know about your private key. In fact, it's great that they don't. You only need to show them your public. So the way you do that is by actually printing out the key using the cat command and going and copying. You're gonna go copy paste this over into DigitalOcean. That's what they're asking for. So let me switch this back around. Yeah, so it says SSH key content. Just paste that in, give it a good name. I'm gonna say, I guess, guide.pem, because that's what I've been calling it. And yeah, well, I guess this is guide.pub, but who cares? So you're gonna hit add SSH key, and then that's gonna add it to your account. Other nodes can use it as well. And so long as you've got it selected, you should be good to go. So we've got everything set up. We're gonna actually make our droplet. How exciting. All right, so we go and create our droplet. Give it a little second to run. Sometimes these resources take a second. There's guide. Funny enough, it showed a little guide for how to get started with DigitalOcean, but this is our guide. So you can see it right here. It's currently computing, and when it's finished, we should be able to access it. It'll give us an IP address in a second that we're going to use to actually communicate. Okay, so there it is. There's our little server. We'll actually go and do other stuff with it, but for now, this is of principal interest. We need the specific IP address on the internet of this node. So you click that to copy, and it'll write it to your clipboard. Let me switch back to the terminal again, and I'm going to actually show you how you go talk to your node. Okay, so let me switch this around. All right, we're back to the terminal. What you're going to do when you want to talk to your node is use that SSH thing I was telling you about, okay? I know you probably know what it is, but SSH-I and then the actual key file is how you say connect to the server but authenticate using my key, okay? So just because somebody else has this IP address doesn't mean they're going to be able to talk to your server or control it. You have to actually have this special file that I'm not showing you. So you're going to go and SSH into it. I'm doing this all from memory, by the way. Hopefully it matches the guide that I wrote. But you're going to say root at, and the reason is what user are you logging in as? Oh, you're going to log in as the root user, the user with all the privileges. So you're going to SSH in. You're going to trust it. SSH is a protocol where there's no way to actually establish the authority of the person on the other end. So it gives you that little scary warning, but you're fine. Just hit yes, add it, and here you are at your node. Oh my goodness, isn't this fun? So this is your node. There's a few things we're gonna do to tune this baby up so that it's like ready to go. The first thing is to actually update it. You can see that it is quite behind, and we should be able to just do that pretty simply, and also show you something kind of cool. So in Bash, if you have two commands, you can actually execute them on conditional success. So I'm gonna show you what I mean. So like if I say echo A, for example, and then echo B, I can actually run both of those at the same time, or rather in sequence. So I could say echo A and echo B. What that's gonna do is run command A, and then on success, which echo always succeeds, right? Run the next one. And if I wanted to add a third one, I could say echo C, and now I got 3 in a row. So the reason we're going to use that is we're actually going to update this system in one command. So we're going to say, using our package manager called apt, which is associated with the whole like aptitude package managing scheme, you're going to, which is a pretty clever name for a piece of software that actually gives you the ability to update your system and change what it can do. We're going to use apt to upgrade our system. So first you do apt update -y meaning yes, please update. Otherwise it'll ask you, are you sure? We're going to say apt upgrade -y, and then apt auto remove -y, and then reboot. All right, what's this going to do? It's going to run this command, and then on success, this command, and then on success, this one, and this one. All right. First, it will update. That is, figure out what packages are available to be updated precisely. then it will actually upgrade the packages, go in and, like, you know, make the changes necessary to the system to use the most recent version of the software available to you, and then remove the stuff you no longer need, and then reboot. You don't have to really reboot, but we're going to do it anyways, just, you know, to work with a nice blank slate. We're going to do that. So we're going to update and let this baby run. It could take a little minute. You know, we've downloaded the most recent version of Ubuntu, but that doesn't mean that the actual packages installed on the system are the most recent, of course, right? It is totally possible that, you know, the stuff is, or the stuff needs to be updated, and that's fine. So, okay, we're gonna let this thing run. After that, we are going to add some additional packages using apt. Apt, by the way, isn't just for updating and upgrading. You also use it to get new software. You know, maybe there's a text editor you like. Maybe there is a special set of programs that we're going to need to actually run our Nano Node. But nevertheless, that's what apt does. So I'm just stalling for time. I don't really know what to say. I guess actually we're just going to skip until it's done. So see ya in a second. Okay, so it might ask you, like, do you want to keep the local version of this specific config file for OpenSSH installed? Just keep the local one, it's fine. Anytime you get asked that, just say yes. Oh, here it is asking me it, you know, through text means. Once again, just do the default, hit enter, keep the local versions, you are A-okay to do that. And then, you know, updating should finish. So when it finishes updating, it's going to kick you out. That's just because you put reboot at the end, and it's not like it can possibly keep talking to you while, you know, it's rebooting. So that happens. You just SSH back in using the same command, making sure you use that key file. Now you'll see that we don't have any updates that we need to install. Everything's good. It's ready. It's fresh. There are, however, packages we will need to install. So the way you actually install packages with apt is you say apt install, and then you list them out. So, for example, we're going to need 7-zip. That's P7-zip full, and then we're gonna need, well, we don't need this, but I personally like it, Emacs, that's my text editor. I guess we'll actually use a different one, but you know, you list all the packages you want. Here's a fun one, add SL for the steam locomotive command, and then you just hit enter, and then it goes. It might ask you yes, hit Y, and then you will basically have those packages you wanted. The steam locomotive command, by the way, being SL. When you hit LS, it lists the directory, but, you know, maybe you accidentally type that in the wrong order, in which case it will present you with a nice locomotive. So, you know, those commands give us the ability to do the things we need to for the rest of the guide, in particular the 7-zip thing. So, okay, we're now at this system, and, you know, it's just bare bones. We got nothing going on. You know, maybe we like to tune it up a little bit. I'll give you an example of something you can do here that you're going to really like if you don't know. Go edit your config file for bash using the nano command. This is not the nano cryptocurrency. This is the nano text editor. I personally use Emacs, but I don't want to have to teach you that. So you're going to find that there is a specific line on using a colored shell. I'm sorry, colored prompt. And we're going to set that thing to yes. So I skipped it by mistake. So, oh, right, they moved it around. Okay, yeah, so you're going to uncomment this, okay? And what that's going to do is force your prompt to be pretty. So you hit Control-O to actually write the changes you've made, and then Control-X to leave, all right? Yeah, and so what that'll mean is when you go, when you reconnect to the system, now you get this nice little colored prompt. And who doesn't like colors, right? By the way, if you want to have a second terminal tab open, that's totally fine. You can just SSH in using a second tab, and you'll have two different means by which to communicate with the server. We're going to take advantage of this in a second. So, okay, we now actually have a bare-bones server that now looks a little prettier, and we're going to use it to do the things we need. So, the first thing we're going to want is to look at our system resources. So, you'll notice our home directory doesn't really have anything, okay? It's got snap, don't worry about it. That's a Ubuntu 20 thing. But of particular note is this directory called mount, okay? That has the actual volume that we were talking about earlier. Remember that block storage we did, the 128 gigabytes? Well, that's where it is. It has been mounted to this specific location. if you decided to add your block storage later, okay, it'll give you commands in DigitalOcean to run. My guide, I believe, also covers it, but either way, point is you'll get this block storage. Someone on Reddit was very confused about instead using S3FS. You don't need that. That is completely different. You just want the DigitalOcean block storage. So you're going to have it in mount, okay? So here's the thing. It's nice that it's over in/mount for the ease of our software and to do a really cool trick that's going to let us have our block lattice be on that block storage device. We're going to do the following, okay? We are going to create what's called a symbolic link to that block storage device, okay? So if you do this, check this out, all right? You say, I want to make a link. It's going to be symbolic, okay? And I won't go into like the operating system theories to exactly what's going on there because there's a bunch of inode crap that is quite intense. But all you need to know is that you can actually connect a directory far away back to here and give it some name. So what this is saying is create a soft link or symbolic link from to this directory with the name that. And what that's going to do if you hit ls is create this special folder. It's not really a folder. It's in cyan that is actually this folder, okay? So anything you go put in this folder will show up here and vice versa because they point to the same thing. And importantly too, this -s makes it symbolic. I'm not gonna get into all the different, like, it's complicated, but the long and short of it is this. You can actually disconnect your block lattice and go put it on a different node if you needed to. Maybe you need to go upgrade some stuff or you want to move it around. You can actually disconnect this and it won't just like ruin the system, okay? So that block storage device gives us that additional benefit. Not only can we grow it, we can also go and give it to other servers, you know, play games with that, transfer in bulk huge amounts of data. There's better ways to do that, but you get my point. We've actually basically connected this block storage device to this specific location. All right, now, what we're gonna do next is actually go download that block lattice. The reason is it's gonna take forever, and we're gonna do that and then work on other stuff in the background. So I actually wrote a little command in my guide. Let me go copy paste it over and then explain it to you. So here, this is the command. We'll do it in this tab. We're gonna change directory to that symbolic location, all right? And then we're going to actually go download the ledger from my Nano Ninja. That actually redirects to a storage service, but don't worry about that. Basically, this command wget lets you download a page. We're going to specifically go download our ledger, naming it ledger.7zip. It's compressed is why. And then we're going to actually run the 7zip command and expand it, that ledger, so that we get the entire block lattice unabated. And then we're going to delete the actual archive of that ledger. So, or to say that again, we're going to go download the compressed version of the ledger. We're going to expand it, and then we're going to hopefully, if all these commands worked in sequence, because remember we're using the and, we're going to delete the compressed version of the ledger. All right, so we're going to run that. It is going to take a very long time, and that's okay. You know, go do some other stuff, like set up the rest of your node. Maybe you get enough done that this like 20-minute wait, oh god, I hope it's not 20 minutes, gets done quickly, but I won't make you sit through it. Instead, we are going to actually solve our problems one step at a time while we're waiting. All right, so while that is downloading, we're able to get other stuff done, okay? In particular, we're gonna actually go download an additional piece of software known as Docker, all right? There are other ways of course, getting what we wish, but this essentially creates what's called a container, which lets you, in a abstract way, like control your Nano Node. If you don't know what Docker is, don't worry about it. I'm going to show you the commands you need to know to actually run this stuff on your system. The first thing is you're going to, and you can copy paste this from my guide, okay? You are going to install the following dependencies that I just did, the sudo apt install. This /line, by the way, just means don't interpret the new line as you running a command, continue writing the command. You're gonna install all those things. It looks like it was already on the system, so that's not gonna do much for you. You're gonna add the Docker keyring. So the way that works is you're gonna actually go and essentially let your system understand that, you know, Docker repositories and stuff are authoritative or whatever. We don't have to get into the specifics of GPG, but if you've ever used Tor, you'll know what that is. But anyways, we're just going to continue on installing Docker. So the next command that you actually paste in using the authoritative source that we now consider them to be, we're going to go add their repository, which lets us get access to the specific programs that they create. In order for your system to know what programs they've made, you need to update again. Again, update doesn't actually upgrade the packages, it just lets you know what's available to you. And then we're going to actually run a install command on the specific Docker components necessary to get our stuff off the ground. So I'll just say yes to that and then start installing it. And you should be good to go with Docker. That installs the actual engine. You shouldn't need to go download stuff like Docker Compose. I know some of the other tutorials online say that. Don't do that. There's much easier ways to run a Nano Node. But that's a hot take right there. So to each his own. Meanwhile, over here, in the time it takes to do a Bitcoin transaction, we are still trying to get our ledger. That's okay. I wonder which will happen first. Will we get a block on the Bitcoin chain? Blockchain, that is, or will we get our ledger? Who knows? Anywho, so we go and we download Docker. We've got that all installed. And I guess for the time being, there's really not a whole lot to do while we wait. Some stuff that you might want to know that's kind of fun is there's a command called htop that'll let you actually look at what's running on your system. You can see here in particular, the wget command we did right here is running, and it's been going for a little bit of time right now. It's taking up 25% of one core of a CPU. You're going to actually see that when you go and run your Nano Node, it's going to make a bunch of entries in this list. There's a lot you can do with htop that's pretty cool, but I just thought you guys would like it because it looks neat. So I know a lot of you guys are just starting out with programming because you're watching this tutorial, but there's so much cool stuff that you can show off and be like, oh my god, my system's so neat. So we've got that, we've got the steam locomotive command, there's other crap we could download, but in the meantime, we're just gonna skip ahead to our node. Actually, you know what? Let's make a directory called admin that I think you're gonna like for actually querying your node quickly. That's gonna be kind of nice to have. So, okay, see you in a second. Okay, so back to DigitalOcean actually while we wait. We need to erect a firewall. That is, make it impossible for adversaries to take control over our node from remote, or from across the internet. So if you actually click on your node, you'll find, you got your CPU graph, your load graph, memory, disk IO. This was the metrics thing we set up a second ago. You can actually see all the stuff it's doing. My ledger, actually, by the way, finished downloading, but I forgot to actually tell you about this step. You can actually see that, right? Like the bandwidth goes down, and now we're just sitting at essentially neutral. So it's humming, but we don't yet have our Nano Node executing on it. But you get ready, because this graph will absolutely reflect the fact that it is a Nano Node very soon. The reason we're actually looking at this, one, is to actually check some stuff out. So, for example, if you check volumes, you can actually go and see the thing that we have connected to it. See, there's the 128 gigabyte unit. Thankfully, it now has the ledger. It took absolutely forever for that thing to download, so I guess Bitcoin beat us this time. But in terms of networking, we are actually going to add a firewall, okay? So the way you do that is you say edit, and oh boy, I have a lot of firewalls, but we're actually going to make our new firewall just for this. Name it something like Nano Node. I think I already have one named that, so I'm going to say guide firewall. The way it basically works is you're able to restrict traffic over different ports. So you have, inbound connections with these inbound rules, and then you have outbound connections. We have no reason to restrict the outbound flow of our, network traffic, but it's the inbound stuff, right? People trying to mess with our stuff that we need to be restrictive about. As for the droplet to apply, just search for your droplet here, because we're actually going to place it on that droplet, and then we're going to just add some rules. So By default, the only thing open is SSH. That's, by the way, the port for 22. It uses protocol TCP over 22 to establish SSH. You don't need to know about like network theory or whatever, but the thing we're going to add is a custom rule that's going to expose port 7075 over TCP. You don't really have to do this anymore because network's now fully TCP. I'm sorry, Nano is now fully TCP, but you can also go add UDP exposure. So what this essentially does is the specific port that Nano uses to communicate with other nodes on the network, you're going to leave open for the world to see. They're going to be able to talk to you through it. The port you absolutely cannot expose by mistake is the one up. You can never allow 7076 to be open because that's the one that lets you control your node. So yeah, you're just going to do that. I'm pretty sure I actually have a diagram with exactly this in the tutorial. Yeah. So see, you just expose those two. Hetzner, AWS, it's the exact same story, okay? They're going to have some table, and you put your rules down and all that. But anyways, you're going to say create firewall. It's going to add that firewall, and if we go back to our droplet, we should see that it's present. It definitely is, but I'm just going to make sure. So you can actually go see that we've got this specific firewall active. You can actually add multiple firewalls, so and use the same firewall for multiple servers. So maybe you make a Nano firewall and you apply it to all your Nano nodes, for example. But anyways, okay, so that's the firewall step. We're now going to go back to our node. Okay, so we're back at the terminal. It should be complete by now, although I'm realizing what I'm going to show you here you could have also done in parallel, but since you're on YouTube, that's really not a big deal, because you can move backwards and forwards, as I'm sure you've been going over certain segments multiple times in a row. So basically, you're going to find that it has created this new file, data.ldb, which is known to be the block lattice based on how big it is, because what else would that be? You can see using the human readable format of the du command that it's 42 gigs in size, so it is quite large at the time being, and will grow over time as your node runs. So now we're going to actually do some Docker stuff. And again, you could have run this while the thing was going, but whatever, for clarity's sake, this is actually fine because you don't have the directories littered with a bunch of crap. So first, you're going to pull in the latest version of the nanocurrency project. Right here, this will download Nano by default. If you're instead running a fork of Nano, like Banano, for example, you would use that. If you're using a specific version of Nano, maybe a pre-release to an upcoming update, you'd instead specify the tag. You just got to go look at the Discord or one of the community pages on what's available to you. When actually there are pre-releases to be had, but the vast majority of the time you're just going to use the latest version, and that's what we're going to have here. So yeah, you hit that, it's going to download a bunch of stuff. I accidentally ran it earlier without recording, so that's why it's already finished for me. But yeah, that right there is going to download the image on which you're going to actually from which you're actually going to create your node container. And this gets really, really cool. So copy over from my guide the docker run command. What this is essentially going to do is allow us to create an instance of the node software from the image we just pulled in. So maybe the way you think about it is we just pulled in the blueprints with that docker pull command, and now we're actually going to build something from those blueprints. We give it some options. For instance, we tell it to just, automatically restart, except in scenarios where we've manually told it not to. Run in the background, so we're not having to log in to run our node. It's just going to always be there. We've given it a port mapping concomitant with the Nano Node software. In particular, remember we exposed 775, so we actually have those ports available to us right here. We've exposed to the world UDP and TCP on that port. We gain access to 776. That's the actual RPC port where we control the node. If you remember, that's the one you definitely can't expose to the world. And then there's also this extra one where if you wanted to have a if you wanted to have a WebSocket with your node, this is the one you would use. You'll learn how to do all that later, but for now, just give yourself access to it. Then we say its location is the Nano symlink we made. If you recall, right, we actually have this folder right here, which is technically actually, you know, mapped over to here. And what this is essentially doing, oops, I didn't mean to do that. What this is essentially doing is saying like the root for the Nano Node container is going to be this specific location. In that way, everything that it actually does, which of most importance is the actual ledger process, is actually going to be stored here. Okay, so that's why we do that. We name it Nano, that's pretty straightforward. And then here we're saying use the image file, in particular the latest version of it. That was the one we downloaded by default, by the way. If you don't put anything, it just downloads the latest. Now, if this was a pre-release, you would instead do colon something else. If this was a different cryptocurrency like Banano, you would change this out. You get the idea. It's all kind of the same thing for this, you know, process. So you might have noticed it spat something out at us. This thing right here is the unique identifier, the hash, so to speak, of this process. And if you run the docker process command, which is docker ps, you can actually see it. So here it is, okay, E1, 1F, you'll recall, is right there. It's kind of abbreviated. In Docker, you just need to have as many letters as is uniquely, or as lets you uniquely identify this specific container that's running. So you can see that it's been up for 2 minutes. It was created, it's been up for 2 minutes. It was created 2 minutes ago. There's its port mapping below. Yeah, and this is the specific image that it was built from. You can actually interact with your node, which is what we're absolutely going to do. So for example, we're going to stop our node so that we can make some configuration changes. So if you issue docker stop, and then the hash, or as much of the hash as uniquely identifies this container versus all the others, it's the only one, so you only need to really type an E, but I like to do more than one letter. You actually then let Docker know that, like, hey, this thing needs to stop. And if you go list your processes, you'll see it's not there because by default it only shows you the ones that are running, but if you do -A for all, then you get this one right here. So it was created 3 minutes ago, but it was exited 11 seconds ago. So we now have this running, living instance of the node, except I guess right now it's not so much running because it's stopped. But yeah, so what you'll notice is if you actually go look inside that directory, we've now got a lot more files. And the reason is that when that nano process got going, it started creating all the things that it needs to actually, you know, be the nano node that it was supposed to be. So, like, for example, it's got, you know, this nano directory, which we're going to do some stuff in a second, and then some other files and whatnot. This data.ldb, remember, we actually pulled in. We're going to use that in a second. I guess let's go ahead and do that. So if you go into this directory, what you'll find is, looking inside the actual nano folder, there's the ledger that it started creating, okay? So let's actually look at the size of it. It should be very small. That 680 megabytes tells you that it is certainly not the same ledger that we have right here, okay, the 42 gigabyte one that we just downloaded. Now, the way Nano works is if you don't supply it a ledger, it will actually build one from scratch in a process known as bootstrapping, and that's what's going on here with this specific ledger. We want to skip the bootstrapping phase, so, or rather the vast majority of it. So what we're going to do is actually replace this ledger with the one that we actually, you know, unzipped and all of that. So the way you do that is you just go and move your ledger into the other. All right, that did it. So if we actually go check that ledger, you'll find that, oh, look, it really is 42 gigabytes now. Oh, by the way, this tells you to use the last argument from the previous command. So the last argument here was this, and I just intuitively did that, but I should have explained it. If you, you know, put that, then it means substitute it with that. All right, anyway, so now we actually have the lattice that we downloaded from earlier. Now what we need to do is actually make some configuration changes so that the node will behave as we want. I'm assuming here you're wanting to make a representative that like votes and actually participates in the ledger or in the creation of the ledger. So, you know, we got to actually tell the node, hey, do the things requisite of that. And there's a few things we need to set up. So in the first file we're going to edit is this config config RPC file. Of import here, is adding the following line here. Okay, we're going to say, let's see here. We're going to make the following change. Actually, we don't need to add anything, get started here. We're going to say enable RPC control. So what this will let us do is make dangerous RPC commands that, stuff like, send Nano to someone else or create a wallet, etc. This will let us actually over, our port, or port 776, perform the commands we want. So write out using Control O, exit using Control X, and now the RPC has been edited as we wanted. The other one we're going to edit is config node. So same thing kind of, but what we want here is to add the following section for describing how the node part of this actually behaves. We're going to say enable control true. All right, write that out and exit. So that's going to have now made it such that the, I messed that up. We're going to say enable voting true. So this node is going to actually vote. Sorry guys, I just woke up. I went to bed earlier and now I'm here, so I'm kind of tired. But it just looks like on YouTube that this was all one recording or whatever, but it's definitely not. So if you found this guide helpful, definitely give me a like or something, because this stuff took way longer to make than I thought it would. But that is okay. We're figuring it out. So we've now made the configuration changes that we need. What we need to do now is actually start our node up again. If you remember the hash, you can just do docker start and then the hash. But if you don't, you can say docker ps-a, go, oh, right, our hash was E1, 1F, etc. And then say, okay, let's restart that process using the new files that we put in those different locations. So now when the node starts up, it's going to notice, oh, whoa, I have access to this ledger that's much bigger, and it's just going to use that, okay? So, it should be doing precisely what we want, and, actually making the progress on that lattice, not starting from the very beginning, but, building from the version we just pulled in and expanded and all of that. So, okay, now this thing is actually alive and going. You can't really tell that unless you start interacting with your node, okay? I mean, yes, you can see that it's been up for 32 seconds, but we need to actually start making some requests to it to see that it's doing what we want. So the way you typically talk to your node is by making get and post requests, actually I guess really post requests against your node. So, you might not know what that is, but basically, in web services, there's different kinds of what are called HTTP requests. When you go to a website, you might say, hey, I want to get this specific web page, and then the server responds. Well, we kind of have a similar concept here, okay? You go make a request to your Nano node, and then it makes a response. So, for example, let's say we want to know how many blocks are in the ledger, okay? You would say curl, which allows us to, from the command line, make a web-like request. -G, don't worry about that, it's just for globbing. And then -D for making a post version of a request. If you don't know what these symbols are, it's okay. What you have to care about, though, is the actual contents of the request we're making. So -D lets us make a post request, which can give us the ability to add in this, what's called JSON set of parameters to the request. If you say this, what you'll essentially be doing is making a web request using the payload to perform the action block count, which I'll show you a page where you're actually able to see all of the different actions you can make against your node, against the process running locally on 776. Okay, so this is our Nano node. You can actually see the linkage right here. 127.0.0.1, by the way, is localhost, but yeah, so this right here is being bound to there. All right, so if we run that, then, well, the node's right now still getting started, so we get this recv failure. Don't worry about that. It just means that it needs a few more minutes to, get up and running. But, yeah, if you make this request, you'll actually have talked to it. And by the way, since it actually responded with this connection reset by peer, we know that the request made it to the Nano node. It's just not going yet. I know many people saw this when doing my guide and they were like, oh my gosh, what's wrong? And then they started sending me messages about it. No worries at all. Sometimes the node just needs a little bit to go, especially considering the current conditions we're in where there's a lot of spam and stuff. So you might have that. I guess then I'm going to show you the actual RPC commands that you have available to your node. So let me pull that up. Just search Nano RPC into Google and you'll actually get the RPC protocol. Let me switch this over. Yeah, so the RPC protocol is basically, if you remember, we did the whole block count thing, so you just scroll down to the command you want, block count. You just substitute out, instead of saying action block count, whatever other thing you want to do. So for example, let's say I wanted to know what other nodes were online. Okay, well there's actually a command called peers that will let us do that. You go click, the command you want. And if you instead say action peers, you'll then get a list of all the different nodes that are connected to your node, okay? And there are so many different commands that do so many different things. We're going to see some of them in this guide because we're going to actually set up a wallet and stuff. But I just wanted you to know that there's this whole list of RPC commands that you have available to you. That should be clear running this thing. So we're going to go back and try once more. All right, so we're still coming up. I guess then while we wait, let's actually go save some of these commands that we might want to use all the time into some files so that you don't have to copy it every time you want to actually run it. So here's how you do that. That admin folder I was talking about, let's go over to it. Let's actually create a file with the contents of the command we want. So I'm just going to call this count.sh. If you go paste in that actual command that we just did and then save it the same way, remember Control O for writing and then Control X for leaving, you'll actually find you now have this file that actually has the contents of that command, right? If I cat it, you see that. If you want to make it a file though that you can run to perform the command that's actually contained therein, do chmod +x on the file, and that will say, hey, I want to be able to additionally execute on this file. And now, when you just run the file by doing / and then the file, you actually get it actually performs the, it will actually perform the commands as laid out in the file. And if you had multiple lines, it would do more than one command. So now we've actually got a little count script. So I'll leave creating additional scripts to you. Now that you see how to do one, it should be very straightforward to turn any of these commands into little scripts that you can then run on the fly. But eventually it's going to be the case, maybe 15 minutes have to go by, that running the actual command gives you an output, okay? It tells you how many blocks you've got available, the ones that are unchecked and the ones that have actually been cemented and finalized into the lattice. And the point of this command isn't really to show you the output, it's just to show you that we've got an output. We've actually communicated using the script with our node. So yeah, you can now swap out this action block count for a whole lot of other things, okay? In particular, we're gonna, in a second, actually make a wallet. I will say, if your node takes a long time to finally get to the stage, like let's say it's still doing recv failures 30 minutes later, just once again, look at your process, and then instead of doing docker stop, do docker restart, and then the actual hash available. So you're gonna do that if it takes way too long. It shouldn't, but just letting you know that that's available to you in case things go really wrong. They shouldn't though. So okay, we've now got the block count. Let's actually make a wallet being our mechanism for becoming representative, as well as storing funds and doing all that jazz. So the first command you're going to run is wallet create. Okay, so the only thing we've changed here is instead of block count, we're doing wallet create. And that is actually going to give you a secret that you should definitely save elsewhere. Now, this isn't a nano seed or anything, but it's something you need to actually perform the wallet command. So set this off to the side, make sure you write it down, all that crap, and you should be good to go. So we've now created a wallet on this node. the wallet is empty, so we need to actually go and create an account on the Nano Node. So using that wallet looks like this, okay? We're going to use the account create command and additionally pass in one more parameter, okay? The wallet within which we're going to be making a new account is going to be specifiable by the actual hash of that wallet. So if we actually go paste in for the second argument this specific wallet ID, we will now create an account. And there we go. We have just created an account which our ledger, or I'm sorry, which our node will use for all of its stuff. So this is our own Nano account. The wallet, the actual node knows the seed to it. It didn't print that out for us. But yeah, this is yours. If you send funds to it, you will have control over anything sent there. And you'll be able to use commands and stuff. So to speed up actually funding your account, you can just copy paste that over. Or if you actually look in my guide, I made a little tool. Let me switch over to it. This little part right here, if you go paste in your Nano address that you've just gotten, it will create a QR code specific to you. You know, you can go load up Natrium or what have you, scan it, send it some funds, and then it gives you this little hot link to my crawler Nano Spider for this account. Now, this account's not opened yet. I haven't sent it anything, so it's not particularly useful to click that. But yeah, you know, just send it some funds. You'll need 1,000 by default in order for your node to run. I made a little tool where you can basically, for free, obtain that much rep, perform the send command with a very tiny amount of nano, like this much or more, and you'll be both funding, you know, my nano efforts and all that, but more importantly, gaining access to 1,000 voting nano. You can also change some stuff in your config file so that it'll just be voting anyways, but for some reason, this is kind of where the community wants it to be, or rather the Nano Foundation. Like if you go look at their guides, they act like no, you must certainly have 1,000 nano. Yeah, so obtain 1,000 nano however you want, or rather 1,000 nano worth of voting weight however you want, and then your node will start voting according to the way we've set it up so far. So yeah, that's basically it. You now have a node that does all of the things you want it to. You know, you've got your account with which you can actually perform the things you need for the Nano network. You can, like, you know, hook this into programs, instead of doing curl requests from the command line, you could like maybe have a Python script or a Node.js file be performing these web requests against the node, and it will be able to respond accordingly and interact with the ledger. It's really exciting stuff. A few notes. At this point, you can kind of do whatever you want. You could go import a different seed and, you know, maybe have like a named account so that like or a vanity account so that it looks pretty or whatever. I personally just chose to go with the first account that it generated. You know, that's kind of a preferential thing. But yeah, just go look at the RPC commands. You've got all sorts of stuff you can do. Golly, this is so exciting. I can't believe it. We made it through our guide. Yeah, so basically, you now know how to create a Nano node. And if you run into any problems at all, feel free to hit me up, okay? And not just me. The community at large will be more than willing to help you out if you go to the Discord. But I'm SaunderDev, 9364 on Discord. You know, feel free to DM me. I have so many people who go and tell me that, hey, I just made a Nano node, and it's extremely exciting. It makes me happy. So yeah, I wish you guys the best on your journey. It's kind of crazy, right? So like for me, I literally started about 11 months ago and suddenly became the #1 Nano node after Binance delegated to me. I'm not that anymore, but yeah, it's crazy. If you actually go and you have uptime and you go tell people about your node, you never know who might go delegate you some weight. Just make sure to do the right thing with it. Make sure your node's always up to date. Make sure that, like, you know, you use that good hardware, all that stuff. Anyways, subscribe for more if you want to learn more about how Nano works and, you know, some of these technical things, and maybe see some of my guides. I'm thinking maybe of doing like a faucet one, or a, like, you know, how to change different versions, etc. So, all right, the sky's the limit. Best of luck.